Hi Kapil,
Hi,
welcome to Sudeep Audio's channel.
thank you.
A quick introduction to you is you're a part of the Andy Munro Acoustics, and you are in charge of the Indian division.
Yes.
You have done, I think, every top composer's studio, the design of the studio in this country. One good thing that I know about you is you just handle the design and you don't get into the selection of the equipment, or you don't force your clients to kind of buy from a particular place, nor influence them to do something, but essentially leave it up to them and decide what they
It's
want.
their choice at the end of the day.
Exactly, and that's a very good approach that you've kept for yourself. You are known to be a little expensive, but then I guess so are BMWs and Audis and Mercedes of the world. So if people want that quality, they have to spend. However, we have a lot of viewers from outside Bombay, or I mean, from different parts of the country who might not be able to justify the costs because of their markets not giving
Yeah,
them,
probably starting up,
or they're just starting
starting up
off
new
and
guys. Yeah.
they're newcomers, and right now they're not in a state to kind of get you to design or
Mm-hmm.
Munro to design the studio for them.
Mm.
It'll be great if you could share some tips and tricks of what will help them build a relatively better studio with their local carpenters or
Mm.
designers. You could also tell us what not to do. There are many things that are happening which is not in the right direction. So if you could share your expertise, it will be wonderful.
I've been talking to a lot of people who want to do project studios and stuff, and they keep telling me that they read a lot of stuff on the internet
Mm.
and they
Because
get
it's
ideas. Yeah,
easiest to,
they get
yeah.
a lot of ideas. Now, it's good to go to the internet, It's but how do you know that's credible information at the end of the day?
Mm.
There are a lot of things on the internet. Use X kind of product, use Y kind of product and stuff. But then you would go through the process, build your studio. At the end of the day, you will say, it's not working for me. Then how do you know it's credible information at the end of the
Right,
day?
right.
There's so many views. There's so many. I haven't seen much of studio design talks on Indian websites.
Yes.
But say if you have studio forums, or there are a lot of other home theater kind of websites.
Yes.
But then they talk about their own locally available materials.
Yeah.
Then how do you know what to use in India? So
Correct.
they might be talking about certain properties and certain aspects of that kind of material over there.
Which is not available here.
Yeah,
Or
it's not available. Even there, even if you have some kind of alternative to that, but how do you know it works and stuff?
right.
The easiest way is just to read a couple of acoustic books, or some professional books, or some papers by BBC and stuff, which looks boring because they don't have fancy pictures on it and they have some graphs on it, but then they talk the simple rules of acoustics and do's and don'ts over there. There are a lot of calculators on the internet as well, I've seen, which are Excel based, which say this, you put your room dimension, we'll give you room modes, and we'll tell you what foam to stick here. People have to understand that foam is not going to solve your low frequency problem, which is there in all the rooms, in all the small rooms at least. And neither would 2 inch of glass full with in a 2 inch framing would do that. That's just
A
people didn't know.
shortcut.
Yeah, people
Or
don't know much about it. And people still do it now. They'll still drop fiberglass on the walls with in a 2 inch framing. They'll put fabric on that, and then they'll
that's
say
not the right method.
it doesn't work that well. Use
Uh,
48 density fiberglass
yeah.
has a certain characteristics. So the alpha coefficients, how the absorption coefficient is called alpha, and you would see, if you just see the graph of that, it tells you how much it absorbs at every third octave frequency. So it will absorb X at 63, 125 and this. And if you clad all your walls with that, at the end of the day, the total surface area of your ceiling walls with in conjunction with your fiberglass would give you that kind of room response. And it
Right.
doesn't absorb anything below 63,
Right.
which is where your problem stands in
Right.
rooms,
Right.
in the low frequency band. So
No.
it has to be a mixture of
Right.
different treatments. In small rooms, you have to have diffusion.
Okay.
Diffusion very important for small rooms as well. With in addition to the absorbing the low frequency.
A very basic question is, you said the room doesn't sound right. That is a very standard line we hear, that it's not a very good sounding room. How does one know whether this is a good sounding room or that is not a good sounding room? Is there any way of judging
It's your ear. We have analog ears. We have to judge that. But you can also have tests to see what the RT time is. So there are a lot of terms used in the industry. Say that it's not tight. The room is a little muddy, or it's not sounding right. I'm not getting that factor in that the frequency, or my subwoofer is not giving me that punch. There, basically, it's just different terms, normal terms used for addressing different frequency bands.
Right.
So if it's muddy, then there's lots of overlap between different frequencies over there, and you can't really distinctly separate them out.
Right.
If it's not, you can't hear the punch, or is that so because of room dimension, whatever the room dimension is, so the subwoofer is not exactly giving you that much amplitude at that band it's supposed to work at.
Okay.
So you can't hear those frequencies, so it's not giving you that punch, which you're trying to feed it a certain signal, but it's not giving you that output because it's being cancelled out in the room.
Right.
With small rooms, the problem is standing waves.
Okay.
And a lot of rooms, at least in India, are a standard 10 feet by 9 feet. By
That's because people are making
in
home
their
studios.
homes, in their homes.
Yeah.
Real estate is expensive. You can understand that. Everyone doesn't have the advantage of buying a property or renting a commercial property with more height. But that's the general format: a 10 feet or 12 feet by 9 feet with 8.5 feet or 9 feet height.
Yes.
One thing is people always sit in the middle of the room, which is wrong. Or they'll when they'll put this kind of treatment on all the three or four sides, they'll say center of the room. You have to be ideally 2/3 of the distance from the speakers. But now we have to make 10,000 clients sit behind. So they want to have all the studio design. They talk about is how many sofas we can fit behind it.
Okay.
And so that's not important.
That's the brief you get.
That's, it's an advertising studio. The production comes. You have directors. You have the staff from this. You have to put everyone in the room.
Correct.
So that's a general thing. That's their idea. That's their input they're giving at the start. But people know the basics about you need to have your speaker at 60-degree angle and having the equilateral triangle and stuff. And then certain websites say, or certain brands of loudspeakers say that you have to keep 1 meter away from the walls. If you're keeping 1 meter away from the walls, then you have your speakers. You'll have a 2 or 3 feet distance between the speakers, and you're up against the front wall. So how I do it is get an AutoCAD drawing, print it out, a blank thing, and start scribbling on it to see what is happening where. The door location is very important. Most of the houses we have, the door is on the long side at the end of the thing. So it doesn't give you, and the door frame is abutted against the back wall. It doesn't give you any space to put any kind of low frequency treatment over there, because that's where you need most of the treatment, because the speakers are firing into that angle. So if you have the option of shifting the door by 6-8 inches more towards the front wall, you should do that. So it gives you that much gap behind to put treatment. After the door position, I would like to know what kind of speakers are being used. So people say we haven't decided yet. I say we haven't decided yet. How would I know? You're telling me you're going to use a 6.5-inch driver speaker, and then tomorrow you'll get a bigger one, and then I wouldn't know. At least not the brand, but tell me what kind of monitoring you use. You use a near field or a mid field monitor, or you use. Today people have large format monitors in very small rooms today.
Right.
So it's very important to know that to start with. Place the footprint of that kind of speaker at the front wall. See where the 60-degree coming up to. Get the mix position or the sweet spot, and then you go back into room modes, and then you draw room modes into the thing into the drawing. You have to compute it on the computer, then see what are main frequencies, how low do you think the loudspeaker will go to, and would that be a problem with the actual the room modes found by the actual dimension of the room. If that's a problem, you go start again, you scribble it out, start again. If it's not, you can work around it. Then you start placing treatment on the front wall. Many times there was a debate about live end and a dead end, and so we feel in small room you can't afford to have a live end, dead end. You have to have balanced treatment. It could be full range absorbers or low frequency absorbers, strategically placed so that it works overall in the room. So how I would do it is have a lot of angle based straps, the low frequency absorbers made of membrane absorbers. Basically, low frequency, with the amount of energy the low frequency bands have, it has to have a vibrating surface for it to be absorbed. Any amount of glass wool, rock wool, or foam you place will not absorb that. It has to have the vibrations have to be converted into heat or any other form of energy, and that can happen through a vibrating panel. Place the front wall with treatment like that. Accommodate space for your television and all your other points and stuff. Just so that in future when you want to come back to the design of that, there has to be a pipe running up for all the other cables doing that. Then you go on the side walls. Side walls usually we use full range absorbers, which are a combination of a membrane absorber with a foam kept in front of it. The amount of foam which would be put, the thickness of the foam will all depend on the thickness of the treatment you're going to do, the base trap you're going to do on the side walls. That usually is 6 inches to 8 inches. So what band you are supposed to absorb, you would either make the vibrating panel 100 mm or 150 mm, and the rest of the depth would be used by foam. So you use foam ranging from 2 inches, the minimum you have to use, up to 4 inches is the maximum you use. Place it around the side walls. Don't clad the whole wall with foam. Unnecessary will eat up most of your the high mids and high frequency, which you don't want. You want some kind of live element in the room. If it's a control room, now people just think wherever you have every square inch, use that. You should not see any bare wall. It's not a problem. You have to place it in the certain parts of the room, so that it works better. You don't have to clad everything and then say that, oh, my room is very dead. But you're eating up all the energy. You're placing treatment in every part of the room. The foam is placed basically 12 at a center of 1250 from the floor. 1250 mm is the average height of a human being's ear, and that is where what matters is when you place a speaker, tweeters as well, they're also ideally at 1250 mm high. So that's where you need a foam, because all the frequencies will be falling on that band. So depending on what kind of monitors you're going on, above 1250 and below 1250 you place a slab of foam, and that's what covers the mid section of your room.
Great.
On the back wall we always use diffusion over there. People use QRDs. We feel in small rooms QRDs have a lot of phase difference, and you can't afford to have a phase difference in in any signal in the room, because you're in such a tight space. You won't be able to figure out what is the phase, and you might be mixing the wrong stuff. So we use a combination of curved diffusers and slotted diffusers. Which basically it is a tuned membrane absorber with a flexible membrane in front with slots inside it. We show you some pictures later, and the slots basically are designed up to what range of frequency you want to diffuse back in the room, what you want to get absorbed. So you place the slots accordingly, and the thickness of slots, it varies from 25 mm, that's 1 inch, to 2 inches, and they're placed all over the room just to have a random kind of thing over there, a random design. Also at the back of the room you're having your producers and other people sitting. Yes. So you can only have one mixed position or sweet spot, you call them. You can't have multiple sweet spots.
So what you're saying is the musician or the composer or the engineer sitting in that room, he should tune the room according to where he is going to hear them.
Yes,
but the producer sitting behind him,
they are supposed to be in diffuse field.
But they will also get a good sound, or
they get diffuse
or they have to come in the front and
if they want to listen to what the guy is listening, they have to come.
But at the back, will he get a sound that he will like, or will he find it muddy, or will he find it?
He'll have diffuse field over there. Okay. So that's what he's going to hear. He like, I haven't seen many producers going to technicalities. They leave it up to the engineer.
Okay.
So he knows what he has to, what levels he has to.
They don't interfere in.
I wouldn't know.
Okay.
It's a working style of it. But ideally, they should bring a diffuse field behind.
Okay.
So they are just listening to the first the direct wave, right, without any getting reflection from that. If you have no treatment on the back wall, or if you have absorption on the back wall, they could be hearing a first reflection or a second reflection, which they're not supposed to hear. Then they get confused. Then they get muddy. It means I'm hearing something here and I'm hearing a reflection from that as well. It adds up, it subtracts sometime,
right,
and then you are hearing something else. So if it's diffuse,
then this,
so it's a diffuse field, and you're hearing a direct sound from the speakers over there.
Okay.
And it becomes easier for the engineer also to, not to redo again, tell them to pump up 3 dB or 6 dB, whatever they want.
Correct.
So it's a balance. It's a win-win situation for everyone.
Right.
And so that's the back wall. Windows are good in the room, but they are good in the front. That's between the monitors. Just to get light in, or get in some sunlight in, or just to have a view or something. We are stuck in situations where we have windows on the side walls. Yeah. If it's on the back wall, then you have to change the design. It's not ideal. We can work around it, but then you have to angle the glass accordingly. So just again on the plan, uh, here you use the light ray model, which is basically you assume that the speaker is only throwing out the HF, so then straight lines, and see what the reflection is like. Okay. So the first hard reflection is going back to this thing. You have to angle the glass in such a way so it goes and hits on some treatment, not directly to the back wall.
Right.
So you play around with that, and that's what we do in normal control rooms, where we have a window looking into the recording area. We angle the glass accordingly. Okay. And we angle in two planes. That's one is in the vertical plane and the horizontal plane. So one, so that there is no reflection onto the engineer as well. So once you're taking care of the energy on the back wall, and also you're taking care of no reflections to the engineer. He'll be hearing a hard reflection from the glass otherwise. So windows, doors are also easy. I know people have made it very difficult. All you need is good mass in the door. In India, we get 38 block boards, which are used in normal doors and stuff. They are not soundproof, or they can't do much. So people use a 2x2 framing, and they'll stuff rock wool in that and put two plies over there. It's also hollow, because rock wool is, at the end of the day, even if it's the highest density of rock wool is 96, it still is fibrous material. So you're having two thin layers of ply, and you're having a fibrous material in between. It will absorb some energy, but it will not absorb all the LF energy you want. So the way to treat that is get a fire retardant door core, which is available in India with local manufacturers.
Is all this material
everything is available in India? Yeah, it's everything available.
Even small towns and. I mean, I'm not saying really small towns, but it's easily accessible. It's
normal building material. Achha. Like stuff like rock wool and the foam, you might have to get it from bigger cities, But you can always, when you're stuck with stuff like that, you can always go to HVAC engineers or people who make HVAC, because they use that for thermal insulation. So that's why you have to know the exact thing, and you can source it for any of these guys. Okay. It's not difficult to source these things.
What about the floor and the ceiling?
The floor treatment? Yeah. So in a high-rise building, you're always worried about neighbors.
That's the biggest problem.
So if you're if you have a neighbor who you don't want to disturb on the upper floor, you have to have a barrier in between the slab and the program material being played below. Normal construction in India, in residential buildings, the slab thickness is 125 mm to 150 mm. Everything acoustics works on the mass law. So the more mass you put in the path of a sound wave, it absorbs or it blocks more sound over there. In that, you have to double the thickness of a wall to get a 6 dB reduction. So if you have a 150 mm wall, you'll have to make a 300 mm wall, which is 1 foot wall, just to reduce few dBs knock off to few dBs. When you talk about 6 dB, that's the ideal case scenario. In the actual practical world, it might not be 6 dB, because there are a lot of flanking parts. Flanking parts are basically your structural columns and your beams, which run across from one flat to the other, because they're supporting a building. Yes. So they are all your flanking parts. So the performance of your wall all depends on the flanking parts as well, which is all the metal going into the beams, into the other. So that will be the weakest point, and the sound will go through that. And it's not practical to make a 1 foot wall or a half a meter wall. Just like. So in acoustics, we work on a principle of a mass spring damper. Okay. It's basically a rigid mass which is has a spring element. The spring element could be an actual spring. It could be a rubber neoprene or a rubber element, or it could just be air. So air also has a springiness to it. Many a times people have the regular way of making a 2-inch frame with the fiberglass, and they put a 2-inch air gap behind. Now the air works as a spring if it's enclosed in a space. If air would leak out from the space, it loses its springiness. It's just that if you imagine a closed beaker and you try to push something through it, the air would resist it being closed. But if you make holes below it, the air will escape out. So there's no spring action to it. So by making the principle is the thinking is right, but it's not being executed properly.
Correct.
Like the air is allowed to escape through that, so it will not work as a spring mass damper.
Right.
So for spring mass dampers, you have to have a mass. So this mass could be gypsum, plywood, MDF, yeah, on a rubber element. Now MDF and all these things cannot be fixed to a rubber element directly. They have to be on a framing, or they have to be on metal channels which are used in gypsum ceilings or in wall partitions. So you have the mass. The mass depends on what level of isolation you want. From now I'm talking generally about any element. It could be the ceiling, it could be a wall, it could be a floor.
Okay.
So you have gypsum. Say we use gypsum for the walls and the ceilings, not for the floor, because it would break easily. You have gypsum. You have a supporting member. It could be a wooden frame or a metal frame onto a rubber element, and the rubber element is fixed to the hard wall. So we have a spring action working on the hard surface.
Okay.
And that also is like a tune vibrator, as I was talking about the treatment before.
Right.
That this would absorb the very low frequencies, and this sound energy is converted into mechanical vibration. Some of it is absorbed by the infill material. Any air void you make, you have to put an infill. You can't have an air void without an infill, and the infill could be rock wool. Preferably rock wool. It's cheaper and is better than fiberglass or glass wool or any other foam. And always the air gap you have, 50% of it should be filled with the infill material.
Okay.
That being, at two hard surfaces, you have zero particle velocity. So if it's a wave, the maximum velocity of the particles is in the center. So if you place the rock wool less than the center, it won't absorb that much energy. Be absorbing the 30 or 40% vibrating particles. You have to be at the maximum. So whatever air void you make, you fill it 50% with rock wool. The best infill material today is rock wool, 64 density. It's readily available. It's not expensive. It is cheaper than fiberglass.
Yeah,
it works better. It is better than the byproducts of petroleum which you are getting, which are the polyfills and the other, like, are used in pillows and other stuff. Because I've been reading about it on the internet and a few research papers in London that it can cause cancer, because it's a petroleum byproduct.
Okay.
And rock wool, though it's itchy and it's irritating, but it's a natural process of mining. It's basically a mineral wool. These rubber elements we're talking about could be used in pipes and duct lags. A lot of HVAC products are used for anti-vibration. So you could use these are rubber hangers used for the ceiling, and you could have wall suspenders or this for the walls. For the floors, you need a neoprene element, and usually the products used for the floor are bison board. Basically, bison board is cement bonded particle board made of wood chips. You can use a normal particle board as well, and these are not expensive. You use bison board if you want to have a lot of density, and if you have a subwoofer, and so you need that much density on the floor, and you don't want to load the floor also. You have to also think about structural loading. You can't just adding mass. You can't, without thinking about it. Normal flats are designed to a specific furniture load and stuff. They are not designed to loading
Heavy.
putting a static load for a longer time.
Okay.
So it's a safety issue. If you're on the ground floor, doesn't matter. You can load the thing, but on the higher floor, you should take care of that. You should talk to your someone who has knowledge about structural loading, and probably an architect or interior designer also. They also have a good clue. So again, you have a void. You make a rubber element. You have a framing on that. You place your particle board and the other. You could use particle board, bison board. You could use MDF, 18 MDF as well. But with the MDF, if you spill water, it starts to get spoiled and stuff. It just sucks in the water. So you could use other stuff which is little water repellent. And I always encourage people to use wooden flooring. It could be laminated, it could be hardwood. Carpet is good, but carpet is very difficult to maintain, and it doesn't, what to people's belief is, add to the absorption.
Right.
Carpets are 10-15 mm thick,
Right.
and they are hard woven carpets, and they're not going to absorb a lot of energy.
Great.
Have a practical wooden floor. It's easy for the chairs to roll, easy to maintain, and carpet over time. If we have a lot of moisture in India, at least in Bombay,
Right.
and don't have mold and other problems.
Right. Earlier we used to have curtains and heavy drapes to also absorb sound. And
But that would require a lot of space. The thing
is that also recommended in case in a house if you?
in a house you could always have a normal window, and you can have a heavy curtain like a velvet curtain. So
Yeah.
the air gap formed between the glass and the
Is
will
that
absorb
also
energy.
a decent
Yeah. For the home use it's fine.
foam is fine?
Yeah, but with the thing with glass is with bigger panes of glass, they also have their resonant frequency. That's why even if you put a thick glass, if you see glass in studios and stuff, thick double laminated or double glazed unit glasses, you can still hear the traffic noise outside.
Okay.
Because it just resonates.
Okay.
So the idea is to have two different thicknesses of glass stuck together.
Okay.
So one resonates at one frequency, the other one the other one. So one blocks one range, one other blocks the other range.
Right. I mean, thanks for all your inputs here. I mean, I'm sure people will realize that what you do is not an easy job. It sounds simple, but when you go to execute, there are a lot of intricacies involved.
It's practicality. Practically also there is since we've been doing studios and other entertainment facilities, you have a fair idea about what is happening.
That's true. That's true.
product-wise
That's why
and
you're where you are, and the leading acoustic guys in the country.
stuff. There are many good
in the
many good guys in India.
Yes, there are. But you're one of them, and thank you for
No problem.
sharing time with us.
I'm always happy to share some knowledge of mine.
Thank you, Kapil.
Thank you.
Bye.
Cheers.